Hello, Tony Golding here from Centrify. In this demo we'll take a look at a hybrid IT scenario. Our fictitious company, Banzai, has been using Centrify Identity-Centric PAM on premises for some time now. They're using it to secure access to their data center servers. However, they're now standing up workloads in the cloud and they want to achieve three main goals. The first, as a Centrify customer already, they're managing their Windows, Linux, and Unix servers as well as network devices and their users centrally from AD, and they're setting up rights, roles, group policies, etc. from there as well. So they want the same for their new cloud instances. They want to bring them under the same Centrify management. Secondly, on their EC2 instances, they want to completely automate the entire process of downloading and installing the necessary Centrify software, configuring it, joining the new instance to Active Directory, and vaulting local privileged shared accounts such as root. Finally, they want to enable secure remote access to these new instances automatically so that IT can start using them immediately. So we're going to step into the shoes of an IT administrator as she works in the AWS environment to create such an instance, fully installed and enabled for secure remote login from Centrify's privileged access service. Just a quick note about this demo. If it was fully automated as we might expect in a proper DevOps world, there wouldn't be much to see. So my demo is semi-automated with some manual steps just to give you a better sense of what's going on under the covers. Let's start at the AWS Management Console. We'll click the button to create a new instance and select a published Red Hat Linux Enterprise AMI at the default tier. Next, we'll configure the instance details. On this screen, I'll make my instance part of a VPC I've already created. I'll also check this box to give me a dynamic public-facing IP address just for debugging. In production, of course, we wouldn't want to enable our instances to be directly accessible publicly. Now let's move to the critical bit from an automation perspective, down here in the user data. This is where we can specify some commands to be run automatically to further configure this instance. We can type them into the box, but I already have a configuration file I've created that contains all my installation and configuration commands. Now you can find this and other examples for Chef, Puppet, Ansible, Terraform, etc. on our GitHub page. Now let's take a quick look at this script and what it does. Scrolling down to the main run function, we're getting some instance environment information. Here we're getting Centrify client software from our repo, installing and configuring it, configuring SSHD, vaulting the root account, joining this system to Active Directory, and the ability to record privileged sessions on this box. Moving on then, let's accept the default storage. In the tags, let's give our instance a name, AWS Linux DevOps 2. Now I've already created a security group that enables communication between instances in the VPC and establishes SSH from our existing AWS-hosted Centrify connector. All of this can also be automated using a variety of DevOps tools. The final step is to select an EC2 key pair, again I created earlier. I'll be using this for debugging, but it would be removed in production since Centrify would control all logins to the box. Okay, let's go to our list of instances. At the top is a new instance. As you can see, it's still being configured in a state of pending. It will take a little while longer, so below is one that I baked earlier using exactly the same technique. Let's now hop over to our privileged access service and navigate to the system list. Now there you can see this earlier instance. If I select this, you see that our script configured a proxy account. Most of our customers won't want to enable root login via SSH for obvious security reasons. So in our script, we created a local account called Centrify proxy that will be used to remotely log in, followed by an automatic SU to root to establish that privileged session, and without the password being revealed, of course. In the Accounts tab for this Linux system, there's the vaulted local root account. Let's go back and see if everything was automatically set up for me to log in with it. As if by magic, a session is established. Note there was no VPN involved, so we're not network attached and we avoid the risks associated with VPN-based access. Now, as mentioned, the SSH login was using the Centrify proxy account. And as you can see on the screen, we automated the SU to root. Okay, let's go back to the system list and we'll refresh the screen. There you see the new instance automatically enrolled here in our cloud platform and available for secure remote login. Note the enrolled name matches the AWS instance ID that we created earlier. Let's double check that this has all worked. Yep, it certainly has. That worked great, and so all the Centrify services are clearly installed, configured, and working as expected. What about session recording though? I'm going to type the words Pink Floyd here in the prompt. Now let's hop over to our Orders and Monitoring service. I'll do a quick search for Pink Floyd. There you see a session match from today. If I open that up, you'll see the session we just concluded. So Centrify Auditing and Monitoring service is also deployed and working as expected. So to summarize, you can easily automate the creation and configuration of your EC2 instances using user data and scripts as I demonstrated here. Or for full automation, Chef, Puppet, OpsWorks, or whatever your favorite orchestration tool. Of course, you're not limited to AWS. You can do similar on other platforms such as Microsoft Azure and Google Compute Platform. You can configure lots of other things we didn't show here, such as MFA, workflow for access request, and risk-based analytics. Thank you very much for joining. Please visit our website for more information about Centrify Identity-Centric PAM.